Hello there, welcome to Chapter 8. Chapter 8 is all about factoring. Now factoring is actually pretty fun, but before we can get to the good stuff, we gotta kind of review how to factor numbers and prime factorizations and all that good stuff. So first of all, just a reminder that a prime number is a number that has exactly two factors, itself and 1. And the number 1, often people think that's a prime number, but it's not, because it actually only has one factor. Okay, because it is 1, so it just has one factor, so it's not a prime number. So I'm gonna show you two ways here of how to factor numbers, and again, you can kind of choose the one that works for you the best. First, here we have a factor tree. Now I think you'll probably remember these. And that's where we just come up with two numbers that multiply to be 98. Now just off the top of my head, I think of 2 and 49. I could pick other things as well, that's just what I thought of first. So then, 2 is already a prime number, so I can't factor that anymore. But then I could make 49, 7, and 7. And then once I have all prime numbers at the edges of my factor tree, I can say that the prime factorization of 98 is 2 times 7 times 7. Now another method that we have is called the ladder diagram. And what this is we take 98, I'm going to put it in like a little half of a rectangle here. And what we do is just divide it by prime numbers. So let's say I divide that by 2, that's going to give me 49. Now if I divide that by 7, that's going to give me 7. Okay, and then I keep doing this until I get down to 1. So again, I can divide by 7, and that's going to give me 1. Once I get to 1, I'm at the end of the ladder diagram, and then down the side here I have my prime factorization. 2 times 7 times 7. You can see that either way I get to the same place. Whichever one works best for you, I guess, is the one you should use. Let's look at a couple other examples here. I'm going to do the factor tree on part A. So the first ones I think of are 8 and 5. And then 8 can be 4 and 2, and then 4 can be 2 and 2. So my prime factorization would be 2 times 2 times 2 times 5. You might also see this written as 2 to the third times 5. You could write it either way because it means the same thing. Over here, let's use the ladder diagram. So I got to divide this by a prime number, so let's say I divide it by 5. It'll get me to 9. I can divide that by 3. It's going to get me to 3. I can divide that by 3, and then I get to 1. So you can see my prime factorization there would be 3 times 3 times 5. Or again, I could also write that as 3 squared times 5. Either one works. Okay, so that's the first thing you'll be doing, is just writing prime factorizations of numbers. Now the next step is to find the GCF. Now if you'll remember, the GCF stands for greatest common factor, and we'll be using this a lot as we go kind of deeper into factoring. And I'm going to again show you two methods. Now the first method works, but sometimes it's not the most efficient method to use. Sometimes it is, depending on how big your numbers are. But let's take a look at this one. Okay, so if I list the factors of 10, or of 100, I mean, so I got 1 and 100. Let's see, I got 2 and 50. I'm actually going to do it this way. So 1 and 100, 2 and 50. Let's see, I got 4 and 25, and I got 5 and 20, and I think, oh, and I got 10 and 10. Can't forget about that. Okay, so I kind of list out all the factors that I know. And then for 60, let's see, I'd have 1 and 60, 2 and 30, 3 and 20, let's see, 4 and 15, 5 and 12, I'm running out of room here, 6 and 10. Okay, so I list out all the factors that go into 60 and all the factors that go into 100, and then I look for the biggest one that they have in common. And you can see here, I think that it is 20. So the GCF would equal 20. Okay, so that's one way. Now you can see that it's pretty easy, but it would be easy to miss some factors sometimes. And I mean, if it's bigger numbers, you got to kind of do a lot of thinking, which isn't a bad thing, of course. Now the next one I want to show you is called the prime factorization. So let's take 27 and find its prime factorization. Now again, I could do this either with factor trees or with ladder diagrams. It wouldn't matter. So I figure out that 27's prime factorization is 3 times 3 times 3 times 3. And then for 18, do the same thing. 9 and 2, 3 and 3. So its prime factorization is 2 times 3 times 3. Now what I do here, once I have their prime factorizations, is I look for pairs. Okay, so I have a 3 here and a 3 here, so I know that 3 is part of the GCF. Now I also have another pair of 3's, so I also have another 3 in the GCF. Now that's the only pairs that I have, so I times those together, and I figure out that my GCF is 9. Okay, so with the prime factorization, once I write them, I look for pairs, and then the pairs, however many pairs I find, I multiply those together, and that gives me whatever the GCF is. Okay. Now next up, we add some variables into the picture. So let's do a 15x to the third here. Well, again, let's write its prime factorization. Let's just deal with the 15 here at first. Well, its prime factorization is 5 and 3. So its prime factorization would be 3 times 5, and then I have x, x, and x. Now let's do 9x squared. Well, if I break down the 9 again, that's 3 and 3. So this prime factorization would be 3 times x times x. Now again, I'm going to look for pairs. You see I have a pair of 3's here, so that's going to be part of my GCF. I have a pair of x's, and I have another pair of x's. So my GCF is going to be 3x squared for these two monomials. Alright, so it's kind of the same idea, just we got some variables in there as well. Let's look at another one here. If I break down 8, that breaks down into 4 and 2, and then 2 and 2. So its prime factorization would be 2 times 2 times 2 times x times x. Now if I do 7y to the third, well, 7's a prime number, and then I got y, y, and y. Now what you'll notice is that we have no pairs. Okay? So in that case, we don't have a greatest common factor. Well, in fact, it would be 1, I guess, if you wanted to write that. But, yeah, there's no GCF. Or I guess I'll look it up and I'll let you know when I see on Monday whether we should write 1 or whether we should write GCF. I don't remember right off the top of my head, but you kind of get the point. Now, the last thing we have here is some fun little story problems. Now, story problems will kind of ask you two different questions here. So we have a cafeteria has 18 chocolate milk cartons and 24 regular milk cartons. The cook wants to arrange the cartons with the same number of cartons in each row. Chocolate and regular milk will not be in the same rows. How many rows will there be if the cook puts the greatest possible number of cartons in each row? Now, the first part of the story problem is that we need to figure out what is the greatest possible number of cartons in each row, for each row to be even. Alright, in order to find this, we need to figure out the GCF of 18 and 24. Okay, so again, let's do some factor trees here. Figure out their prime factorizations. Alright, so 18 is 2 times 3 times 3. And 24, we got 6 and 4, 2 and 3, 2 and 2. So its prime factorization is 2 times 2 times 2 times 3. Okay, so what's the GCF of 18 and 24? Well, let's look at our pairs. We got a pair of 2's, and we have a pair of 3's. So the GCF is 6. Okay, so that means that there should be 6 cartons in each row. Okay, but we're not quite done yet. So the greatest possible number of milk cartons in each row is 6. Find the number of rows of each type of milk if the cook puts the greatest number of cartons in each row. So let's say I have 18 chocolate milk. So if I have 18 chocolate milk and I have 6 per row, that's going to be 3 rows of chocolate milk. And if I have 24 regular milk, again 6 each row, that's going to be 4 rows of regular milk. So in total, and this is what the question is asking, how many rows will there be? There will be 7 rows of milk. Okay, so that's kind of how we figure out the story problems. Okay, so pretty much we find the greatest common factor, and then we take the totals and we divide it by the greatest common factor to figure out how many rows we have of each one. Okay, if you need another example of that, I have another one, so just ask me about that on Monday, and I'll see you then.